Hi children, today I am going to explain about the next part in the chemical equilibrium. In first class, what is chemical equilibrium, types of chemical equilibrium, concept completed. Now, state of chemical equilibrium. Just take a chemical equilibrium reaction. A plus B gives rise to C plus D means here A and B, these two are reactants. These two are involved in the reactants to give C and D. These two are the products. But the small a, the small b indicates this is a small a is a number of moles of capital A. Means how many moles of capital A taken in this reaction means A moles, B moles. Then how many moles of C and D are formed? C moles of C and D moles of D. Okay, Nana? Right. So, in any chemical reaction, either in irreversible reaction or irreversible reaction, we observe rate of the reaction. Sir, first what is rate, sir? I already explained what is rate. Generally, rate means decreasing the concentration of the reactants or increasing the concentration of the products. For example, in one reaction, a reactant gives products. So, in the beginning of the reaction, at the initial time, only concentration of reactants are present. There is no products. Okay, then once you start the reaction, when increasing the time, the concentration of the reactants decreases while concentration of the product increases. So, the concentration decreases is equal to the concentration increases. Sorry, concentration of products increases. Concentration of reactants decreases is equal to the concentration of products increases. This decreases, simultaneously products increases. Okay, the time calculation, the change calculation in 1 second time. In 1 second time, how much concentration of reactants decreases or how much concentration of products increases is called rate of a reaction. This can be explained by using one graph. Simple graph representation of a state of chemical equilibrium means, see this is rate of a reaction on y-axis, in x-axis time. Okay, initially this is the concentration of the reactants. Initially there is no concentration of products. As the time increases, concentration of the reactants decreases. At the same time, concentration of products increases. These two are exist equilibrium at a particular state. This state is called state of chemical equilibrium. Okay, in irreversible reaction, the concentration of the reactants decreases while concentration of products increases. So after some time, after half an hour, after 1 hour, the reaction is completed. The reaction is completed means, for example, after half an hour, for completing for this reaction, half an hour time is enough. After half an hour, there is no concentration of reactants, only concentration of products is present. But in equilibrium reactions, the decreasing the concentration of the reactants and decreasing the concentration of products, both are attained one state. This state is called equilibrium state. This state is called equilibrium state. Okay, so this is equilibrium state. Okay, what about this one? This is forward reaction. This is the backward reaction. Okay, and what is a rate of forward reaction? This is a rate of backward reaction. right? So in equilibrium reactions, once you attain the equilibrium state, there is no end of the chemical reaction. Simply, this is the equilibrium reaction. So in equilibrium reaction, after attaining the equilibrium state, reactants are converted to products. At the same time, products are converted to reactants. Okay, Nana? What we are observed at equilibrium state? At equilibrium state, rate of forward reaction is equal to the rate of the backward reaction. Means both forward and backward reactions takes place with same speed. Okay, or same changes of concentrations in both sides. Second, two opposing reactions occur at the same speed. We know that same rate means same speed maintained both opposing reactions. Opposing reactions means forward and backward reactions. Third point, concentrations of reactants and products do not change with time, because at equilibrium state, that is fixed, continuously reactants to products. So concentration of reactant decreases while concentration of product increases. At the same time, again the concentration of products decreases and increasing the concentration of the reactants, because forward, backward, continuous reactions. Next point, temperature, pressure, color of the reaction, density, etc. These are all measurable properties. We can easily measure them, but they do not undergo any further change at equilibrium state. At equilibrium state, there is no further change in the temperature, pressure, color, density of that reaction. Right? Next point. This is also we know very well. Number of moles produced per second in forward reaction. In forward reaction, how much product is formed? How many number of moles of product is formed must be equal to the number of moles disappeared. Disappeared means again the product is converted to reactant. So in backward reaction, same number of moles are again converted into reactants. Means formation at the same time disappearance. Again involvement in the reaction. Both are takes place at the same time. Formation at the same time converted into another product. Both are simultaneously observed in the equilibrium reactions. Right. Next point. Carried out in closed vessel. Equilibrium reactions must be carried out in closed vessel. Why? For example, if any product or any reactant present in the gaseous form, there is a chance to evaporation from that container or from that test tube. So that's why if you maintain in the closed vessel or closed test tube, if any gaseous products or reactants are present, there is no chance for escape. Okay, that's why it must be carried out in the closed vessel. Next one, catalyst. So first of all, what is catalyst? What is the role of catalyst in the chemical reactions? Generally, catalyst does not involve in the reaction, but just alter the rate of the reaction. Means, for example, if one reactant is converted to product, it requires nearly 8 hours time. 8 hours time. If you add a catalyst, it helps to complete the reaction less than 8 hours. Means just in 5 hours. That is the role of catalyst. Okay, best example, milk is converted into curd. We added, for example, lemon or red chili. These two are catalysts. These two are converted milk into curd just within 8 hours time. If you did not add any అంటే తెలుగులో తోడు వేయడం తోడు కూడా వేయలేదు అనుకోండి, it takes nearly 24 hours time for conversion of milk into curd. అది కుళ్ళిపోయిన స్మెల్ వస్తుంది. Okay, that is also curd, but we never use it, right? But the catalyst is lemon, just lemon. Okay, if you add the lemon, it acts as a catalyst. Red chili is also. That's why once observe the taste of the curd, it is so to taste, but it not taste like red chili. Okay, chili is taste. That's why it does not involve the reaction, but alter means either speed up the reaction or slow down the reaction. Right? If in the chemical equilibrium reactions also, catalyst does not change the equilibrium state. But it helps in attaining it rapidly. Help chestundante. Right? Next one, 8th one. Dynamic in nature. Dynamic means same speed. Both the reactants move with same speed. So all are move with the same speed. That's why it retains very quickly. Dynamic in nature. Next concept, law of mass action. Law of mass action. What is law of mass action? First, law of mass action was introduced by Caspar Goldberg and Peter Weiss. These two fellows introduced law of mass action. After this point, write the definition. Don't write now, I will tell later. First, I will explain with two equations. In this reaction, A plus B gives rise to C plus D. What are the moles here? 1 mole of A, 1 mole of B gives rise to 1 mole of C and 1 mole of B. So A plus B, these two are reactants, C plus D, these two are products. Okay. According to law of mass action, rate of the reaction. Simply rate of the reaction, right, with small r. Rate of the reaction is directly proportional to the product of the concentrations of the reactants with their coefficients or powers. Two reactants are there, one is A, another one is B. So write the concentration of A. This bracket indicates concentration. So concentration of A into concentration of B. And write how many moles are there? Only 1. So write power 1. How many moles of B is there? Power 1. This is the law of mass action. Rate of the reaction is directly proportional to the product of the concentrations of the reactants with their coefficients. That is the definition of law of mass action right here. But condition is at constant temperature. Okay, for removing this proportionality, these two scientists introduced a constant, that is K. K, concentration of A whole power 1, concentration of B whole power 1. Means concentration of A to concentration of B. Where K equal to rate constant. Okay, Nana? Very easy. Now apply for this equation. Rate of reaction R is directly proportional to the, what are the concentrations here? A and B. So concentration of A into concentration of B. With their coefficients means how many moles of A is there? A moles. So concentration of A whole power A into concentration of B whole power B. Now remove the proportionality, just introduce rate constant K into concentration of A whole power A into concentration of B whole power P. Okay, this is about law of mass action. So law of mass action only depends upon the concentration of the reactants. Okay. Now law of chemical equilibrium. Actually, in law of mass action only one single reaction is taken. But in chemical reactions, two reactions are there. One is forward reaction and the other one is backward reaction. What is the forward reaction here? What is the forward reaction? Forward reaction is, this is forward reaction. AA plus BB gives rise to CC plus BD. This is the forward reaction. And what is the backward reaction here? This is the backward reaction. See this. What is the backward reaction? The reverse one. Reverse one means Cc plus Dd gives rise to AA plus Bb. This is the backward reaction. Now you apply for law of mass action for forward reaction. What is that one? The rate of reaction. And no need to write every time rate of reaction. Just write directly rate of reaction R for forward reaction. So R is directly proportional to the concentration of A whole power A, concentration of B whole power B. Because in this reaction, these two are reactants. Now I apply for backward reaction. RB, rate of backward reaction, is directly proportional to the. In this reaction, what are the reactants? C and D. So concentration of C whole power C, concentration of D whole power D. Okay. Now removing this proportionality, what is that? Rate constant here, forward rate constant, so Kf into concentration of A whole power A, concentration of B whole power B. Now here, removing the proportionality, Rb is equal to Kb into concentration of C whole power C, concentration of B whole power B. But we know that the condition, what is that condition? At equilibrium, rate of forward reaction is equal to rate of backward reaction. We know that condition. At equilibrium, rate of forward reaction is equal to rate of backward reaction. Then automatically these two must be equal. These two means Kf into concentration of A whole power A, concentration of B whole power B is equal to concentration of C whole power C, concentration of B whole power D. Okay. Sorry. Kb is there. Kb. This Kb move to this side. These two concentration terms move to that side. Then we got Kf by Kb is equal to concentration of C whole power C, concentration of B whole power B by concentration of A whole power A into concentration of B whole power B. So simply Kf by Kb, this is equal to Kc. C means concentration terms. Here products and reactants both are present in the concentration terms. That's why Kc. So Kc is the equilibrium constant. Okay. Equilibrium constant in terms of concentrations. So Kc is equal to, no need to write this one. Of course, remember everything. So Kc is equal to Kf by Kb is equal to, we can write simply these two are product terms, these two are reactant terms. So concentration of products by concentration of the reactants with their coefficients. So remember this one. Equilibrium constant independent on the following factors, means it does not depend on the following factors. Equilibrium constant, this is equilibrium shortcut, this is constant shortcut. Okay, but you have to write complete sentence of word. Okay, first one, initial concentration of the reactants. Initially you take how much of reactant, that is not required for the equilibrium constant. Because for equilibrium constant, what you have to write, for example, concentration of C into concentration of B by concentration of A into concentration of B. Okay, na? So it is only depending upon the concentrations at equilibrium state. So not the initial concentration of the reaction. Right? Second one, catalyst. We already know that equilibrium constant does not depend upon the catalyst, because catalyst does not affect the equilibrium reaction. That's why it does not depend upon the equilibrium constant also does not depend upon the catalyst. We know very well about this. Third one, direction. How the chemical equilibrium reactions are going down with same speed in both forward and backward reaction. Means is there any fixed direction for the reactions? There is no direction. That's why for equilibrium constant is also independent of the direction of the reaction. Fourth one, presence of inert materials. Inert materials means inert atmosphere created materials. Helium, neon, argon, krypton, xenon, inert gases. Nitrogen also stable molecule. That's why nitrogen gas is also create inert atmosphere. So if any inert materials are there, that is also does not affect the chemical equilibrium reaction. That's why chemical equilibrium constant also does not depend upon the inert materials. Last one, change in volume. Equilibrium constant only depends upon the concentration of the reactants and concentration of the products, not concentration of the volume. Okay, right. These are the independent of the equilibrium constant factors. Next one, Kc value. Generally, when the Kc value is higher, when the Kc value is lower. This is the numerator part. This is the denominator part. If the numerator part is more than the denominator part, then the torque value is more. If the denominator value is more when compared with the numerator value, it indicates the lower Kc value. Okay, right. Numerator value is more means this is the production. This is Kc is equal to concentration of products. Shortcut concentration of reactants. Okay, now in shortcut manner, what is Kc? Concentration of products by concentration of reactants. Okay, if concentration of products increases means, for example, in any chemical reaction, reactants gives products. If the concentration of products increases means, is it forward reaction or backward reaction? Simply it is a forward reaction. In the forward reaction, reactants are converted to products. If the concentration of products increases means, it is a forward reaction. That's why higher Kc value indicate the reaction must be forward reaction. Okay. If the Kc value is low, when the Kc value is low, if the denominator value is more compared with the numerator value, then Kc value is low. But what is these terms? Concentration of reaction terms. Concentration of reactant terms are more means products are converted to reactants. So it is a backward reaction. That's why lower Kc value indicate backward reaction. These are the independent of the equilibrium constant. Next one, stoichiometric representation of equilibrium constants or equilibrium reactions. Okay now. So stoichiometry means balancing. Stoichiometry means balancing. Very simple. These are all just check the relation between one equation to another equation. What is the relation between equilibrium constant for one reaction to another reaction? Means same reactants products are present. Means same species are present in that reactions. Once see this reaction, A plus B gives rise to C plus D. In this reaction, we must be considered A plus B are reactants and C plus D are products. Now, a reverse reaction. This is the reverse reaction. C plus D gives rise to A plus B. So, C and D are considered as reactants. A and B considered as products. Now, write the equilibrium constant for this reaction. So, equilibrium constant Kc equal to concentration of C into concentration of B by concentration of A into concentration of B. Okay, this is the equilibrium constant for this reaction. Now what about this reaction? Equilibrium constant. The equilibrium constant taken as Kc dash. Kc dash, that is equal to concentration of products by concentration of reactants. So concentration of A into concentration of B by concentration of C into concentration of B. So powers means only one is there, 1 mole each. Okay, then what is the relation between these two? So the relation is very simple. Kc dash is equal to, so this one is equal to reverse for this one, means 1 by Kc. 1 by Kc. So Kc dash is equal to 1 by Kc. So 1 by Kc means if you write Kc value for these terms here, that is reverse. Reverse one comes this one. That is the relation between reverse reactions. Simply, this is for reverse reactions. Reverse reactions. Okay, sir. Second one. Once see this equation. 2NO2 gives rise to N2 plus 2O2. N2 plus 2O2. Now, same reactants and processes observe this reaction. NO2 gives rise to half N2 plus O2. What is the difference between these two reactions? This reaction 2NO2, in this reaction NO2 is there. Means for this reaction, both sides divided with 2. Then we got this reaction. NO2 by 2 means 2 cancel NO2. N2 by 2 means 1 by 2 N2. 2O2 by 2 means 2 cancel O2. So what is the difference between these two reactions? This reaction is divided by 2. We got this reaction. Now write the equilibrium constant for these two reactions. For this reaction, Kc is equal to concentration of products by concentration of reactants. Here first one N2 power 1 means there is nothing means 1 mole into concentration of O2. How many moles? 2 moles. Power 2 by this one concentration of NO2. 2 moles means power 2. This is the concentration equilibrium constant for this reaction. Now write for this reaction. Kc dash equal to concentration of N2 whole power 1 by 2. Concentration of O2 whole power 1 means there is no number, means 1. For this one, concentration of NO2 whole power 1. Now what is the relation between these two, Kc dash and Kc? Just do the square root of this one, you got power 1 by 2. This is, just do the square root for this one. Square root means N2 O2 square NO2 square. So root over N2 root over O2 square means square root cancel, down root over NO2 whole square means square root cancel. So this is root over N2 means N2 power 1 by 2. So you got, if you square root this one, you got this value. Means between these two, what is the relation means? The relation is Kc dash is equal to root over Kc. Kc dash is equal to root over Kc. Just you calculate the square root this one, you got Kc dash. That is the relation between this type of equations. Next model for stoichiometric representation. For example, this is one reaction. N2 plus O2 plus Cl2 gives rise to 2NOCl. This is one reaction. For example, this reaction completed in one single step. If the reaction is completed in two steps, means suppose the above reaction split into two reactions. N2 plus O2 gives rise to 2NO. 2NO plus Cl2 gives rise to 2NOCl. Means this is single step reaction. If the reaction is completed in two steps, for example, one person jumps one place to another place in single step. Same one reaction. Same reaction is completed in just in two steps. The target is same. The reaction completion is same. But in single step, this is single step. Same reaction completed in two steps. So, sir, is that these two are same, sir? Yes, two. Just one, see this one. Reactant side, add these two reactions, we got this single reaction. N2 plus O2 plus 2NO plus Cl2. N2 plus O2 plus 2NO plus Cl2 gives rise to, add these two, 2NO plus 2NOCl. Both sides 2NO cancel. So N2 plus O2 plus Cl2 gives rise to 2 NaOCl. Same, both are same. Now, what is the relation for the equilibrium constants? For example, one reaction is split into the several reactions. Then what is the relation between the equilibrium constants? First, write the equilibrium constant for this reaction. For this reaction, Kc is equal to concentration of NaOCl. This is the product. So into 2 is there, so whole square by products reactants set. The 3 reactants are there. Concentration of N2, concentration of O2, concentration of Cl. Okay, this is the equilibrium constant for this equation. Now write for these two reactions. For this reaction, equilibrium constant taken as K1, concentration of NO whole square by concentration of N2 into concentration of O2. Now for this equation, write the equilibrium constant K2 is equal to concentration of NaCl whole square by concentration of NO square into concentration of Cl2. Okay, now check. We want Kc value, but what we have to do for these two, we got that one. Very simple. Just multiply these two, you got this value. Very simple. Do it. K1 into K2. K1 into K2 means NO square by concentration of M2 into concentration of O2 into concentration of NaOCl whole square by concentration of NO square into concentration of Cl2. These two are cancelled. Now what is present here? NaOCl whole square by N2 O2 Cl2 concentrations. Okay, na? So this is equal to Kc. This is equal to Kc. So for splitting reactions, this is for splitting reactions. For splitting reactions, Kc is equal to K1 into K2 into so on. For example, if it is split into 2, K1 into K2. If it is split into 3, K1 into K2 into K3. Okay, Nana? This is about stoichiometric reaction.